All right, anyway, so 5.4 is on modeling and optimization. So modeling means story problems. Optimization means find max or mins, find like the optimal size of a like soup can, cereal box, things like that. There's a reason why all the cereal boxes when you go to the store are all like the same shape. So you're minimizing surface area while maximizing volume, things like that. All right, so steps in solving optimization problems. So understand the problem, what's known, what's not known, what are the given conditions. Draw a picture. Usually the picture is very useful. Introduce notation. So use things that make sense. A is for area, length is L, width is W. Write an equation. Write an equation using the variable that's to be maximized. Make sure it is in terms of only one variable. So if you had area, make sure you only have like the rest of the equation with width or length or whatever. And then find the absolute max or min. If it's a closed interval, make sure you check the endpoints as well, just like we've done before. So number one, it says you have 40 feet of fencing with which to enclose a rectangular space for a garden. Find the largest area that can be enclosed with this much fencing and the dimensions of the corresponding garden. Okay, so we draw a picture. We're trying to maximize the area. I have 40 feet of fencing, so if I let W be my width, I need to somehow find what length is, so I'm going to call that L. So already, you know, the perimeter is 2 width plus 2 length, and the length all the way around is 40. So you have 2W plus 2L. Besides area, we only want to have one other variable in our problem. So we want to choose either width or length. So pick one of them, it doesn't matter. So let's say I solve for L. I'd have 40 minus 2W equals 2L, divide by 2. So you get 20 minus W equals the length. So that's what I'm going to put in for the length, or for the length, yeah. Okay, my area is what I'm trying to maximize. So my area equation is what I need to write out with length, or with W, I mean. So I'm going to have W times 20 minus W. That's what I'm trying to maximize. So what do you think I need to do? I want to find the maximum area. So it's some kind of function. So how do I find the maximum of any function? Yeah, find when the derivative is equal to 0, right? So we're going to set the derivative equal to 0. So I'm going to do A prime equals. Now notice how it helps. I don't have to use the product rule if I actually multiply this out. So I would write this as 20W minus W squared. So I get 20 minus 2W. Set it equal to 0. So I get W equals 10. I took the derivative.
Oh.
So we want to find the largest area. So I know my width is going to be 10. My length is going to be whatever 20 minus W is, so 20 minus 10. So my length is also 10. So what's my area? 100. All right, and since these are all real-life problems, you need units. So go back, and it was in feet. So we have feet, feet, feet squared. Mm-hmm. Squares are rectangles.
Rectangles, not squares.
And that will happen all the time if you're trying to find the largest area for a rectangle. It's always a square. All right, next up. So a square sheet of cardboard, 18 inches on a side, is made into an open box by cutting squares of equal size out of each corner and folding up the sides. So we've had one like this before, and you guys flipped out and didn't know how to draw it. So 18 inches on a side, it was a square. You're going to cut out the corners, and you want them to be squares that you're cutting out. Otherwise, the height of the box is going to be different. It's not going to be level across the top. You know what I'm saying? Like if this was real long and this one was real short, when I fold up this flap, it's going to be really long. It's going to be this length. When I fold up this flap, it would only be that length. So the heights wouldn't be the same. You know what I'm saying? Okay, so I'm cutting out squares. And these are going to be x by x. So I've cut out these flaps. I'm going to fold up the box. So I get this real shallow box. Oops, that should be straight up and down. I'm struggling on my box here. I promise I know how to draw. Okay, so we get that. Okay, we need to think of the dimensions of the box. Okay, so originally this was 18 inches, and we've cut out x from here and x from here. So this whole length is now 18 minus 2x. Same for this other, 18 minus 2x. And then the height of the box was, when we folded up that flap, do you guys see it? What's the height? X. So we have x, we have 18 minus 2x, and 18 minus 2x. Okay, so that means our volume can be written as, you know, it's usually length times width times height, but we know all of those in terms of x. It's 18 minus 2x times 18 minus 2x times x. Now you can do the product rule multiple times, but I would probably just multiply it all out and then take the derivative, right? So I'm going to have, when I multiply everything out, is it 364? 324? Minus outer and inner are both 36x, so minus 72x plus 4x squared. You're going to multiply the x in. I'm going to write it in order, so I'm going to get 4x cubed minus 72x squared plus 324x. Okay, so we've multiplied it all out. Now we can maximize the volume. So we can find the maximum volume by finding the derivative and setting it equal to 0. Okay, so I get 12x squared minus 144x plus 324. Pull out a 12 from each piece. Okay, what's 324 divided by 12? 27?
This is for today, and I didn't
Oh, okay, that's fine.
And this gets a big computer.
Okay.
Math guy.
Okay.
Physical science.
Okay, thanks. Okay, set it equal to 0. We're going to factor. Luckily, this factors nicely. If it didn't, what would you need to do? Right, quadratic formula. So you get x equals 9 and x equals 3. Okay, what this means is these are critical points. So I'd put v prime on your number line. You're going to test 3 and 9. If you test a number smaller than 3, so think, you can't do 0, right? Why could you not do 0? Right, that's not really, it's not, that's going to be undefined. It's going to be that there's no like height to the box then. It's not really a box. Okay, so let's try 1. So if I try 1 in the derivative, I get 12 times negative 8 times negative 2. So it's a positive number. If I try 6, I get negative times positive, so negative. If I try 10, it's all positive. So remember, that means you were going up and then down and then up. Why does 9 not make sense? Yeah, because then like the length and the width would be 0 as well. So it's not going to make a box there either. Okay, so do you guys see how 3 has to be the max? Yeah, Victoria?
Why do we have to use a number line for this one, but not for the one before?
Okay, so good question. I kind of did skip a step on this one before. I knew that my area was, so my original area was this. So what kind of shape is that, like if I graphed that function? It's a parabola, and which direction does it face? Down. So it went like that. So that's why I knew the max had to be that point. All right, so if you kind of know that, you don't have to do the chart. But remember, if you're doing this on the AP test, you can't even just write the chart. I mean, you can do the chart, but you would need to explain what was in the chart and the reason that you knew that it was a max or a min. So be careful and things like that if it's a free response problem. Obviously, if it's multiple choice, you don't need any justification. All right. So that means that on this problem at 3, that's going to be where I'm getting my maximum volume. If you plug into your original, you'd get 3 for the height. You'd get 18 minus 2 times 3, so 12 for the width, 12 for the length. So your dimensions are 3 inches by 12 inches by 12 inches. I don't care what order you write them in.
Why do we use 3 because it's the maximum?
Yeah, that was the location of the maximum, right? If you were graphing it, 3 was the x value that gave the max. Okay, if I actually asked you to find that volume, you would multiply it out. So 3 times 12 times 12. Okay, so number 3, so find the point on the parabola y equals 9 minus x squared closest to the point 3, 9. Okay. Okay, so I know what 9 minus x squared looks like. I'm going to go up to 9. I can also tell easily where the x-intercepts are. Can you guys tell easily where the x-intercepts are for that without graphing it? So what makes y equal to 0, 3, and negative 3? Okay, so here's what my parabola looks like. Okay, here's the point 3, 9. All right, so a lot of you guys, when you see this, you're like, oh, the closest point on the parabola is going to be 0, 9. How many of you guys think that it's 0, 9? No. Some of you kind of put up your hands. All right. All right, so a lot of you are like, oh, well, it should be 0, 9. I can see that it's pretty close to that point. Okay, but actually the closest point to anything is always, if you go straight, it's like the normal line. You draw the normal line. So you're going to be perpendicular. So it's going to come straight through, and it's going to be perpendicular there. So whatever point that is, that's where the shortest distance is. Yeah, so you can kind of guess, maybe 2, 8. I don't know. Okay, so let's think about how we would find this. Okay, so let's call this point x comma, and I'm not going to call it x comma y, because it's actually on that parabola. So what's its y value in relation to x? 9 minus x squared. Do you guys see that? You just used the equation. So it's x comma 9 minus x squared. So we want the distance from 3, 9 to x comma 9 minus x squared. And we want to minimize it. We want to find that minimum distance. So how do I represent the distance from 3, 9 to x comma 9 minus x squared? Distance. How do I do distance in math? Distance formula, right? Okay, so here's what the distance formula looks like, in case you've forgotten. Okay, it's basically just the Pythagorean theorem. You take the difference between the x's, you square them. So do you remember if you drew out this triangle? Wait, that's not my right triangle, is it? X minus. Yeah, that's my right triangle. That works. So the distance between the x's, the distance between the y's, that finds the hypotenuse squared. Okay, so you could draw on the right triangle if you need to. Okay, so in our case, D is going to be, you can make either one x1, y1. Okay, so I'm going to have x minus 3 squared plus 9 minus x squared minus 9 squared, all under square root. Okay, obviously you want to do some simplifying before you try to minimize. Okay, let's go ahead and FOIL out the first part. So I get x squared minus 6x plus 9. And then my 9 minus 9 goes away, so I have negative x squared squared. So it's going to be x to the fourth. Do you guys see it? And it's plus because the negative was being squared as well. Okay, not much more you can do with simplifying. So now you need to take the derivative. So the first derivative of d, you're going to do, you're thinking of all of this as being raised to the 1/2 power. Are you guys thinking that when you see the square root? So it's x to the fourth plus x squared minus 6x plus 9 to the 1/2. So your 1/2 goes to the front. Now raise to the negative 1/2 times the derivative of the inside. So 4x cubed plus 2x minus 6. So in other words, this is what we have. So on the top I have 4x cubed. Well, let's divide by 2 everywhere. See how it's divisible by 2. And I have a 2 down there. So this is going to become 2, 1, 3. So I'm going to have 2x cubed plus x minus 3 all over the square root of x to the fourth plus x squared minus 6x plus 9. Okay, we want to find when the numerator is equal to 0, and we want to find when the denominator is equal to 0. Okay, if you needed to, you could find both of these on your calculator. You could set the numerator for y1, denominator for y2, and find the zeros. Okay, I can actually do the numerator equal to 0 in my head. Can you guys do it in your head? Think about it. Where did it look like it was? Catherine guessed 2, 8. What'd you say, Grant? 1. Does it make sense that 1 makes the numerator equal to 0? 1 is your answer, right? Okay, now if you didn't know how it factored, like if there was another place where it would equal to 0, you could do synthetic division. You could say, how does this factor? It's like you're doing the rational roots theorem. So you're going to plug 1 in, you'd have 2x cubed, 0x squared, 1 minus 3. So you get 2. 2 times 1 is 2, add straight down, you get 2. 1 times 2 is 2, add straight down, you get 3. 1 times 3 is 3, add straight down, you get 0. So that means that this numerator factored into x minus 1 times 2x squared plus 2x plus 3, all over that square root of the denominator. To figure out how to factor it. You could also find it with your calculator. You could find the zeros with your calculator. All right, and then you can try to use quadratic formula to break this one down further. Negative b plus or minus. We don't have to do this. I'll show you. Minus 4ac. But if you do b squared minus 4ac, b squared is 4 minus 4 times a times c. Do you see how that would be a negative under the root? So what does that mean? 1 is the only real root, right? The others were imaginary. They would have i's. So 1 is the only critical value. And then whatever that critical value is on the bottom, like if there's something that makes the denominator equal to 0, that's not going to be the point that's closest. That would be undefined at that x value, right? Well, no, not in the original, would it? So maybe we should find when the denominator is equal to 0. Okay. So get out your calculator and let's find when the denominator is equal to 0, because we probably should consider that as well. I'm going to pause and get mine. Okay, Okay, so when I graph that denominator, x to the fourth minus, or plus x squared minus 6x plus 9, so not even under the root, I'm just trying to find when it's equal to 0. I got something, whoops, I'm trying to draw. I got something that looks like this. Basically, it's never equal to 0, right? So there are no critical values from the denominator, which is good. Okay, so the only critical value is from 1. And doesn't that make sense that would, like, look at your drawing. Does it make sense that 1 would be the one that's the shortest distance? So your point is 1, comma, plug back in to find the y value. So 9 minus 1 squared is 8. So Catherine was pretty close on her guess because she said 2, 8. It was really 1, 8. So close. All right, so number 4. So we want to construct a box whose base length is 3 times the base width. Okay, when you hear that, which one do you think is going to be your variable, length or width? Length or width? Width, right? Does that make sense? Because if it was length, you'd have to do like 1/3 length. All right, so 3W, W. I drew mine kind of different, but so the material used to build the top and bottom cost $10 per square foot, and the material used to build the sides cost $6 per square foot. If the box must have a volume of 50 cubic feet, determine the dimensions that will minimize the cost to build the box. Okay, so what are we missing? Height. So let's make it h for now. But I know my volume has to be 50 cubic feet. So I know 3W times W times h has to equal 50. So how can I rewrite h so that it's in terms of W? $50 over 3W squared, right? So that's really how we're going to write it. So now I only have one variable. Okay. So the top and bottom cost $10 per square foot. So the top of the box, right here, how do I represent that area? What is it? Right, it's 3W times W, so 3W squared. So I have 3W squared times $10, and that's on the top and the bottom. So I'm going to multiply by 2. So that represents top and bottom. Did you see what I did? Okay, now let's do right and left. So what's the right side going to be? What's its area? 50 over 3W squared, but then times W, right? Because that times that. Yeah, so you can cancel one of the W's. All right, and that's the area of just the right side. And the right side costs $6. And we also want the left side, so times 2. Plus, we need the front and the back. So now this is going to be 3W times 50 over 3W squared. And the sides are still $6 per square foot, so 6. That's representing just the front, so I need the back as well, so times 2. All of this is going to be equal to the cost. So I'm going to say cost, or C. So C equals. You can write it on the right as well. Okay, that's what you're trying to minimize. Okay, so simplify. So I'm going to have 3 times 2 times 10, so 60W squared. Plus, we said one of these W's cancels. 6 and 3 are going to reduce to 2, but then 2 and 2 reduce out. So I have 50 over W. So I'm going to write it as 50W to the negative 1. 3 and 3 reduce out. I get 600, oh, W's reduced out. So 600 over W, so 600 W to the negative 1.
The no value wouldn't, because you already crossed out the 3 on the bottom, there's no 2 on the bottom, you cancel the 2, so it'd be 100.
On this one, this 2 canceled with this 2 there.
But there wasn't a 2 on the bottom. There was a 2 on the
Oh,
top.
yeah, it was on the top. You're right. Thank you. Just see what I did. I got cancel crazy. All right. So 3 and 6 reduced to 2 on top, right? So that should be 4 times 50, so 200, and then 1 W on the bottom. So 200 W to the negative 1 plus 3 and 3. So 600 W to the negative 1 equals C prime. So I want to find when C prime equals 0. So I get 60W squared plus 800. What? I haven't even taken the derivative yet. Man. All right. Oh, you got that one. Okay, so derivative. So I get 120W minus, so I'm going to combine these, so it's really plus 800 times W to the negative 1, so minus 800 W to the negative 2. So now find when it's equal to 0. The best thing to do on these is to get common denominators. So multiply the first one by W squared over W squared. So you get 120W cubed minus 800 over W squared equals 0. So your critical value is 0. Obviously, you can't be less than 0, right, for W, the width. And then the other one, you do 800, so 120W cubed equals 800. Divide by 120, and then take the cube root, so raise to the 1/3 power. So I got 1.882. Okay, you might want to store that in your calculator, so I might store as W. Just in case I'm asked to find multiple things. Okay, so it says if the box must have a volume of 50 cubic feet, determine the dimensions that will minimize the cost to build the box. Okay, so we're just supposed to find the dimensions. We weren't asked to find the minimum cost or anything. Okay, so let's put 1.882 on there. If you try anything less than it, like 1, on the numerator you're going to get a negative number. On the denominator you're going to get positive, so it's negative. And if you try anything bigger, you're going to get positive. So it's going down and then up. That's why it's minimizing. So that's a minimum. So your dimensions are 1.882 by 3 times that, so do times 3. So 5.646. Oh, these are feet too, aren't they? Are they feet? Yeah, so I did inch marks. So feet by 50 divided by 3W squared. So make sure you put parentheses around your denominator. So 4.705 feet. I plugged into here and here. So 3 times W. Yeah. And that's why I stored it, because I knew I had to find multiple things. All right, so go ahead and start on your homework. You guys, we're going to do a lot of these tomorrow, a lot more of these tomorrow, but you probably want to start them so you can ask me questions. So this typically is a hard homework assignment for people, so make sure you're starting it now.